We're going to head towards our panel. So just hang in there, if you would, while we gather our panelists again. For those of you that are on the panel, if you could go ahead and join back in, we would be most grateful. I thought the audience might be interested in our statistics from our 2 days. I'm going to put this in chat just so you can all kind of absorb what we've had here. We have had more than 1,000 users registered for the event, 8 speakers from India, 5 different speakers from Africa, and 14 from the Americas. So, man, everybody's been mentioning diversity here and there. That's a lot of diversity. So we really appreciate that. Also, we've got one more reminder about the learn.omlogics.com for your free learning portal account. It's free. Sets you on a path to learning. So if you haven't done yet, I'm going to put the link back in chat one more time as we head towards our panel, and you can get that before we close. Over the last 2 days, we've had amazing presentations, and today we covered diverse topics from cancer, forensics, space to beauty, drug discovery to Bayesian hierarchical phylogenetic trees. And what brings us all together is our appreciation of the increasing role that bioinformatics is playing in biomedical research and the need for high-quality bioinformatics education, mentorship, and opportunities for students to participate in research. So thank you all for all of this. And we want to thank our speakers once again from today. We will be sharing the recorded sessions on our YouTube channel. And since I seem to be really good at plugging in links to YouTube and all that, there is the link to our postings that we will have. And let's review our esteemed panel. We have Dr. April Wright, Dr. Emmanuel Ruiz, and Ilya Brodsky, who's stayed on with us. And panel, we want to dig in on how students, this is all about the students, how students can learn about bioinformatics and advance biomedical research across the NAIPI regions. So who wants to start with tidy data and what it means to us all?
Yeah, I can start. I think there's often a lot of hesitance to try and get students to do any sort of bioinformatics or computational research. You know, people think, oh, it's going to be really hard. The students aren't going to understand it. And, you know, I'm not saying that it's going to be easy, but I use R in my introductory biology class, and we do some, you know, basic linear regressions to do things like understand organismal scaling or think about how mutations move in a population. And, you know, most students are game to try things. Like that's what they're really good at, trying stuff. And so I think, you know, if we think it's important to get students involved in learning these sorts of skills and to get them to think quantitatively consistently, you know, we're the ones at the front of the classroom. So, you know, there's no one else who's going to do that if we're not going to do that.
Okay, fascinating. Thank you. Emmanuel?
Yeah, I think it's as a student, the possibility to learn the basic tools of bioinformatics, I think is quite crucial and interesting in a way that first I think it will, how to say that, illustrate all the theory that is learned on mathematics, statistics courses in university, and it gives a wide examples of how what we learned in classes can be used and be useful for very global topics. And I think it can help them practice this theory that they learned. And yeah, we need to try. I mean, we need to students need it's easy. I mean, it doesn't need a big brain to begin to learn bioinformatics. it's as I say, and with the OmicsLogic tutorials that help very much. It's quite easy to learn with internet and how to use the basic of bioinformatics, and with very simple examples of how it can be useful. It's quite interesting to learn. And
Thank you.
Sorry, I think it's also very much important because more today, with all this media crazy stuff, learning bioinformatics, biostatistics help to see that all the information maybe are not very significant, but we need some tools to select what can be significant and can be kept after. So it's a kind of also a kind of mindset that is learned to be more, how to say that, more, I don't know how to say that, but more respect.
I'd like to help you, but I don't want to put words in your mouth.
You can have like that, I don't see it. So yeah. Yeah, more
Cool.
Take a step back of what we think, and before to confirm and give a big conclusion on anything, we can use tools that help to say, oh, maybe not, it was not true. It may be, but in the end, it's not true. So we have to be careful. And bioinformatics help to teach this kind of mindset.
Okay. Ilya, I'm going to let you kind of close that up if you want to say anything more about it, and then talk about how students and diversity of experiences. Lead that off too.
Well, I think here we have a great diversity of experience, right? April was saying how she did, a degree in biology and then went on to journalism and ended up doing what she's doing now. So it's a very non-linear path from, where you start, where you end up. And we had a lot of speakers that illustrate that. I mean, people that, maybe started in a completely unrelated space, end up doing bioinformatics. Now, what does that mean for students? I wonder if it is easier for them to see how bioinformatics can be a useful and not an intimidating skill set if they are exposed to it early on, and not necessarily only after they said, I will, master bioinformatics and become proficient at it, right? How can they do that? How can they just try something small, in an elective course or maybe a mandatory course, but not with a high stakes, not like you either succeed or fail, there's a lot of in between. And maybe another thing is diversity from the perspective of this kind of a community, right? I think when you are just like 3 people that do something, it's also very difficult, right? You got to see that there is a greater population of people in different regions, in different universities at different levels that maybe use this in a variety of ways. So I think that it's very important to bring that community together and let students see each other and kind of realize that, it's not just one single type of people that end up doing this.
One of the things I've heard over the last 2 days is how diverse the paths have been. So yeah, April, I'm sorry, go ahead.
Oh yeah, I was just going to say, I think one thing that is worth remembering is that, when it comes to who can see themselves doing computation, almost every high school offers biology, right? A much smaller proportion of schools are going to offer advanced mathematics, computer science, these sorts of things. And so I was writing a grant last year and I came across this stat that, 90-something% of students who major in computer science had it in high school. And I was like, wow, that's incredible. And then I realized, well, probably 100% of students who major in biology probably had biology in high school, right? And so if we restrict this sort of information and this sort of training to people who have already declared an interest in it, we're basically restricting this sort of information and this sort of training by zip code in a lot of places. And so I think, that integration, like Ilya mentioned, in lower divisions, that integration in coursework where it might not necessarily be, the bioinformatics course, but it's something that everybody has to take, I think is probably a good thing if we believe all students should have access to these skills.
Mm-hmm.
Any expansion on that, Emmanuel?
Yeah, no, I don't know, but yeah, it's true. it's true that bioinformatics is so diverse that it will, even for the undergraduate students that still don't know exactly how they want to evolve in their career and how they want to specialize, they will have tools that can help them very easily, because bioinformatics have it's a very, very diverse. And these tools also can be used for other, the same tools can be used for other field, as finance, business, or other activities. So it can be quite very useful. And yeah, and we are, I imagine, because it's a long time I have been a student, but we try to be in the top of technologies, and right now biology have been is so high that the technology are very high tech, and so it would be very interesting for the students to have an access about how this new biology are because of bioinformatics in part. So it's yeah.
So one of the things I could imagine, a student having a hard time asking questions and going beyond the guide direction and going self-directed and coming up with creative thinking. If you don't know how to ask questions, how do you ask questions? Can you guys talk about that a bit? Elia?
Well, I think that's kind of what's missing in bioinformatics, right? Bioinformatics is almost viewed as this like set of skills, do you know how to code? Do you know how to do this? Do you know how to do that? So if somebody gives you a coding problem and they explain to you, this is what you need to do, this is kind of the result I'm looking for, it should look like this. I think, yeah, anyone can follow that. It's much more difficult, I think, for students to feel like they can be creative and kind of thinking beyond those kinds of instructions, and even sometimes spot what they are finding, what is interesting about their finding. Because ultimately as a student, you do a lot of digging, right? And a lot of digging and reworking your problems is because you don't get them right. But as sometimes you kind of stumble upon something that is interesting, right? And then sometimes your expectation might be, well, maybe that was another mistake, but it's not always like that, right? And so you have to almost have that anticipation that every once in a while, you're going to stumble across something that is interesting. And when you do, you need to have, I think, a good way to explain what it is, communicate it to somebody who's more experienced than you, and have that discussion of equals almost, like, this is what I see in data. What do you see? How is this like the correct way to interpret that? So I think that's a skill that you cannot master by, reading a textbook. You almost have to be mentored, be shown an example that, yes, we all make mistakes. We all stumble across interesting findings. And that's what papers are, is like, we found an interesting finding. Now let's try to describe it and validate that it's a real thing.
That's interesting that you mentioned the aspect of digging, because, one of the things I feel like we teach kind of poorly is how to read scientific literature, right? How to pick up the narrative and how to understand it. And so I do some domain-based education research, and I have, one class where we're looking at kind of more straight lecture versus if we incorporate more like learning how to read a scientific paper and then doing sort of Socratic method discussions. And I'm really interested to see how these data come out, because I feel like, one of the most common things that I see in students is not that they come into research and they want to do things, and it's not that they're not bright or they're not, intelligent people. It's that they stumble with the independence, right? And it's like, you learn to be a good writer by reading a lot, right? But when you learn to be a good scientist, you do that by sciencing a lot. But how do you do that in the undergraduate curriculum in a way that, we're constantly shuffling them around, right? You're going to chem lab and you're not a chemist, so you have a lot of instructions. If you're not a physicist, you have a physics lab and a lot of instructions. And there's not a lot of room for independent exploration in a lot of these. And so, having them read the literature and see how other people have done independent exploration, I think is really important. That's a good point.
So, Elia, you kind of talked about something about in the classroom and stuff like that. How much of that stuff, how much of a responsibility do we put on a mentor or a teacher to make sure a student understands it's okay to be wrong, it's okay to walk down the wrong path, it's okay to ask questions?
Well, I'm just going to incorporate this message that I just see in chat from Dr. Amitabh Jayaswal, who's saying, as a bioinformatics learner, my difficulty is that I find it hard to understand concepts of computer science and statistics, although I understand biology fairly well, but those things instill loss of confidence and consequently productivity. Also, when I approach some professors or practitioners of the subject, even they don't truly appreciate the depths. Doing a series of clicks or following an algorithm does not impart real understanding hold. So this disenchant. So I guess what this message means to me is that whether Dr. Jaiswal here is not a student, right? He's already an established maybe researcher and learning bioinformatics, right? So I think if you go into any new domain, you're going to be following somebody else who's saying, this is pretty much the formula of how you get from A to B, right? And I want you to be at B, and at B, something else happens, right? You get a degree. Now, we call you a doctor or whatever it might be, right? So I think this kind of a view of what, research, if you want to be in research, that's kind of like a parallel world that you're living in, because in research, one of the more important things is getting to a point where you stop relying as much on other people that tell you this is how you do things, because otherwise you find it difficult to kind of get away from established truths, which is what you're going to end up challenging in most of your research. So I think that it's something that is much more advanced in the West than maybe in some other more traditional systems of education. So that does exist. On the other hand, I think that the effort to get people faster to this higher level where they can become more independent could have this downside that, people view this as restrictive. So, I think that's where you have to kind of leverage the abundance of resources that are available to, skill, understand, ask questions about how things work and get to that point. But, it's not something that I think you can get from that formal education. The goal of formal education is probably not that.
Also, there is something that I realized on my own experience is sometimes you don't have results, or you have results that you are not able to explain. That can be in biology, but also in bioinformatics. But it's not because they are wrong. It's just maybe they are largely more complex than what we saw initially. And so we need maybe more time, or maybe someone else at one point will understand it. And so you need to be to lower a bit the pressure of the results and say, okay, but maybe it's more complex than what I saw, but it's not wrong per se. Is that something that it can help and not be completely discouraged in the research world?
Anything to add, April?
No, I have to run and get my kids from school though. So thank you for having me. It was really nice to be here.
Well, thank you for being here yet again. So
nice to meet you, Emmanuel, as well.
Nice to meet you too.
Thank you. Emmanuel and Elia, what's coding in R and Python, computational training? Are those going together? How important are those things? I've heard those names throughout the last 2 days.
I guess I want to also ask, what Emmanuel thinks about it. I started learning R first, and I really thought, this is so great. You can just produce these charts right away. They look nice. You can just put them in publications. It was really kind of like an exciting, simple way to get quickly to meaningful results. In Python, just using matplotlib with all the loops and trying to get your chart to, display different colors and annotations, that was such a pain. Until I realized that Python maybe is much easier, in fact, to use in other domains, like machine learning, for example. I find it very easy and kind of intuitive the way that those packages have been built. So I think that there are benefits to, either R or Python in different applications, but it is dependent on kind of where do you see yourself going. Like if all you need from R is to get that plot, and everybody's using that complex heat map to, produce that nice figure, maybe that's enough. But if you are trying to go much further beyond that, build your own application, start kind of working with other types of repositories here and there, that's, I think, where you have to know enough of both to not be afraid and to also be able to kind of, specialize eventually down the road. But, I would be interested to know what Emmanuel thinks about that.
But me, it's simple. I'm still not in Python. I am in R. I imagine I am familiar now with R, and I still haven't found on my application the limits of R where I couldn't use R. But yeah, so for me, R was simple. I will say that I found the tutorials that let me understand R in a simple way and going step by step. And so it's very useful, as you say, for plots, for simple analysis. And like that, in my head, to be honest, I don't see publications that show Python, but most of them show that they have done their analysis with R. So I think it's very useful. But as you say, we don't have to be closed on one software, but see how others can be also helpful. And with the OmicsLogic tutorials, I'm going to begin to learn Python. But
nice.
New language. I didn't want to do both at the same time, even if bioinformatician told me you need it. But I was a bit afraid that if I learn both at the same time, I will mix them and I will don't succeed to improve my skills. So I stay on R. Yeah.
Nice. So let's switch a little bit of this over to the social and emotional aspect of research, especially as it applies to students. Now, I've heard in my world here how many people throughout the last 2 days have stumbled onto something that became important in their lives, but how much impact do students have into research, and then what happens in our world?
I understand this topic to be extremely important from the aspect of research being very discouraging sometimes, right? So I think that research is a very long game. It's not something that you achieve results quickly. And it's something that you're going to fail a lot more than maybe if your goal was, much less ambitious. So it's definitely for people that have the perseverance and the emotional strength, I would say, or ability to, disconnect from their emotions to go over, overcome those challenges. So I think that's one part of it. The social part of it is that being a scientist, you wish you were the person on TEDx talks, discovering, things that change the world, but most of the time you're not, right? So most of the time you're kind of behind the scenes, and your PI is who's out there talking about the discoveries made in the lab. So I think that, if you choose this area of research, and I think that's where bioinformatics actually is going through sort of a transformation. My father is a bioinformatician and has been for decades, and so he was always the one providing data to people who went on stage and talked about the discoveries. And I kind of saw this disconnect between the hard effort that he was putting into his analysis work and whatever the biologist was then presenting. I think today that is becoming much more balanced. Bioinformaticians, there was an article a few years ago that bioinformaticians can finally be in the driving seat. I think that is a little bit of a change and an encouraging change for those that have chosen bioinformatics as their science.
Yeah, I agree with you that the best quality of researcher are perseverance, because that's you will need it. I mean, because it's maybe less in bioinformatics, maybe more on bench work, but you spend most of your time having negative results before to have one positive result. And it's not something that is easy to manage, so you need to have perseverance. And so I think there is one thing that a skill that need to be learned, and it's a long process because it's more a kind of a routine to know how to separate your professional life to your personal life, because research doesn't have end. And it's like when we do a big puzzle, we don't want to stop until it's finished. But at one point, we need to have also a healthy life and a healthy separation between what is research or professional life and personal. And that, I think, honestly, is a skill that need to be learned, because it's not easy, it's not innate. And more when we are students and we are working for PI, or PhD, postdoc, when we are working for people that put us a pressure, it's because they have their own pressure, okay? It's not easy for them too. It's difficult to put this separation, and so maybe learning these two skills, perseverance and separate professional to personal life, is very helpful to have a success in research. And yeah, I think that, as you say, not every researcher will have the Nobel Prize, but it gives us a kind of humility and a kind of encouragement to know that for a Nobel Prize, there was maybe thousands of manuscripts that this Nobel Prize have read, try to understand, use to his own project that have this reward. So in a way, all work participate to the whole science evolution, and that is it's a beautiful feeling.
Fascinating. So you guys touched on something, and I want to kind of go back to it. For students and doing all this research, is there an issue with expectation of result? And I think you kind of walked around a bit, hit it a little harder, because I'm a new student, I know I'm going to find this, and then it's not even close.
Well, I think actually one of the speakers, Dr. Paulson, mentioned that they involve students. It's almost like as a PI, you have to have this, maybe decades or years long project. And if you are able to involve students at different stages of this project, you end up sharing these exciting milestones with them that they feel like they've gotten to a result. So it is, a lot of it is about mentorship with an intent to offer students, not squeeze work out of them, but allow them to get into the field and feel like they are contributing something meaningful, right? So like, for example, in my experience, I've had a number of very established PIs that have included me in publications that, I honestly did not contribute maybe that much, but the fact that, my name ended up on that publication, gave you like, we published in Nature, whatever my contribution was, but, that was a very empowering feeling for me.
I understand. It's, yeah, we have similar experience, yeah, where we work hard. I know my PhD, I mean, my principal project have not been yet published. So it was quite hard, because when we spent 4 years working on it and by discovering new tools by yourself, I mean, it was quite hard. But what I have done, even it didn't get published as we wanted, it helped other teams to build their own their project, and so driving and discovering more about their the science and the breast cancer at this time. So yeah, it's frustrating. I mean, research is frustrating. It's not, you don't have to be blind and go there saying, oh, it's a happy place. It's a frustrating work, but yeah, knowing that even indirectly we participate to this knowledge evolution help to overcome these frustrations. And so to put the pressure lower, because unfortunately the success of researchers are very dependent of what they publish. And so when you work years or months or years on projects that in the end you didn't see any publication, it's quite hard but there is other indirect way to have encouragement. So it's nice to remember that.
Yeah, very good. Well, thank you all. We are wrapping
Thank you.
our time here as it comes to an end. Thank you all, especially Elia and Dr. Emmanuel, for sticking around this afternoon and answering some questions, especially as students, because I've seen a lot of student questions in chat over the last 2 days. So thank you all. To those of you in the audience, please engage with us. I posted our social links a little bit ago, and if you can comment and share there, that would really help our mission. And of course, go sign up for your free account. That wraps up our 2 days of international worldwide learning. I'm just stunned by the level of intelligence and integrity with all the researchers and speakers. Thank you all. Thank you again, Emmanuel and Elia. And that wraps us up. So thank you all so very much.